In this Godot tutorial, I'll teach you how you can make the items in your inventory stackable, and in a follow-up tutorial, we'll make sure we can split these stacks again. First thing we gotta do is update our data structures to accommodate these stacks, so let's get started on that. First up, our item data table. This is the Google Sheet we created in episode number 2 of this mini-series, and we turned that into a JSON. We gotta make sure that we know for each item whether it's going to be stackable or not. Now, in some games you have that all items are stackable, and then this might be an unnecessary step, but if you do want to have both stackable and non-stackable items in your game, we gotta make sure that the data is aware of that. So we have this new column stackable, which I've set to false for every kind of equipment piece, swords, armors and the like, and true for things like potions and food. Now that our item data knows which items are stackable, we also need to make sure we have a place to save the current item stack of every inventory slot. So for that end, I've added in the JSON file a subkey stack for every inventory slot. And for the items that we've already got in there, I've put a number. 1, of course, for the non-stackable items, and a random number between 1 and 3 for all these stackable items. With the data structure done, we can switch to Godot and work on making sure that we represent the stack size to the user in the inventory panel. To show the stack size to the user, I'm here on the inventory slot template, the scene that we instance into the inventory for every item slot. On here, I'm going to be adding a new label to display our stack size, and I'll rename that label to stack. I'm going to be adding some dummy text so we can see what's going on. And the first thing you probably want to do is change the font. So we're going to load a new dynamic font, and I've created this Arial 15 font for that. I think that is going to be the right size, not too big, not too small. Now I want this to go to the bottom right side of the panel. So I'm going to be aligning this to the right side of the label node. And I'm going to, with layout bottom right, push that label to the bottom right corner. Now, of course, now the number is interfering with our borders, so we got to give it a little bit of margin, probably about -5 on the right side, and I would say probably -4 from the bottom. That also means that we have to add -4 to the top. Now, with that done, our label is in the middle, and even if our stack size were to become in the 3 digits, that is all working fine. Now, for maybe a little bit of last final touch, we can add a little bit of shadow to it, and maybe instead of having this a hard white, make this a broken white color, as that's a little bit softer on the eyes. With that set up, we can now clear the label, so we have a label available, but that doesn't load any value by default. Now we can start adding code to actually make use of this label. Under the script of inventory, which is responsible for loading all our items into the inventory, we can add 3 lines of code to use that label. While we're looping over every inventory data key, we're going to define the item stack size by using that subkey stack we've just added to the JSON file of the inventory. Then, based on 2 conditions, we want to make sure the item stack is not null, which means there is no item in this slot, and the item stack size is at least 2, meaning that for every item that only has a stack size of 1, we're not going to be displaying the label. That makes the inventory look a lot more clean. Then, if that is both true, we're going to get the new inventory slot that we're currently working on. We're going to get that node stack, the label that we've just added, and we're going to set the text equal to the string of item stack. Now, if I hit play, we will see that our items that have an actual stack size, a couple of these chocolate cakes and some potions, are now displaying the correct stack size based on our inventory data in the game. Now we gotta work on our functionality to actually stack some items together. For this, I'm gonna switch over to the code of the inventory slot, where we'll integrate this stacking functionality with the drag and drop functionality. First off, once we start dragging an item, we wanna know 2 things. First of all, we wanna know, is this item stackable in the first place? And second of all, what is the stack size of the item we are dragging around? For the stackability, we can use the game data item data table that we added that column stackable to. So we're going to look up, just like we looked up the original equipment slot, based on the item ID that we know is in our inventory data, and we're going to look up the column or the subkey stackable. That is going to return true or false. Next, we have the origin stack, which is of course data that we can get out of our inventory data itself. Scrolling down to our canDropData function, I've already added two new lines of code, line number 37 and line number 42. These two lines of code don't contribute to our stacking functionality, but they are important for when we move and swap items around like we used to do. Before, we of course had to make sure that our item IDs stay up to date in our inventory data and that we moved around the textures so that the user actually sees the items swapping and moving. Now that we also have added the stack size, we gotta make sure that the stack data and the stack label are still updating properly whenever we're moving or swapping items around. In order to do that, we need to retain the data of our target stack so that we can use that whenever we actually drop an item into another slot. To stay with the theme of making sure that moving and swapping items around remains functional now that we've introduced stacks, let's have a look at our drop data function and the code we have to add to accommodate these stacks. When we update the data of the origin, we were updating our inventory data item subkey with the target item ID. Now we can do something very similar for our stack size, where we update the inventory data stack subkey, the key that we added to our JSON file, with the target stack. Next, when we update the texture of the origin, we'll say that we update the texture and the label of the origin. We are doing that by checking for two conditions. We check if the data target stack is not null and the data target stack is bigger than 1. The same conditions that we used on our load sequence for the inventory to check if we need to show a label, yes or no. If this is true, or if both actually are true, in that case we get the origin node, the stack label of the origin node, and we set its text to the data target stack. Now there's an else statement here because it could be that the origin label was already filled when we originally loaded the inventory in. In that case, we want to reset that label to nothing so it doesn't display any weird information. To do that, we get the data origin node, the stack label, and we set the text to nothing. There's one catch here though. It could be that the origin node is an equipment slot, that we dragged something out of our equipment panel to the inventory. The equipment slot doesn't have a stack label to approach, so this get node would return an error. We only want to do this reset of the label in case the origin node originates from the inventory itself. Therefore, the else statement checks if the origin panel is the inventory. Finally, we update the texture, the label, and the data of the target. To update the data, we simply gonna get the inventory data, the stack subkey of our target inventory slot, and we update that with data origin stack. For the label, we check against the same two conditions. We check if origin stack is not null and bigger than 1, in which case we get this node's stack label, and we set the text to the data origin stack. Otherwise, we are going to reset that label. In this case, we're dealing with the target node, and the target node is always going to be an inventory slot as we're working inside the inventory slot script. Therefore, we do not need to check any panel is inventory like we did here on line number 73. There is one catch though with this code, and that is that on line 79, if we're setting for data origin stack, once we drag an equipment item out of the equipment panel into the inventory, we've never set the origin stack inside our data dictionary inside the equipment slot. There's two ways we can circumvent this. We could either check for inventory panel, or we could simply go to our equipment slot and we can add these two lines, line 18 and 19, to the code. We know that in my case, an equipment item is always going to be an equipment stack of 1 since it's not stackable. And since it's not stackable, we know that stackable is going to be false. So we can predict these values with 100% certainty. And just by hard coding them in here, we don't need to write any extra code here and make any extra exceptions, which is also going to be handy once we start implementing the code for splitting stacks. Now we can start working on actually making our items stackable. To make our items stackable, I'm gonna have to be updating every section of our drop data function inside our inventory slot. First up, the update of the data of the origin. I'll replace this if-else block for an if-else if-else block, in which the first statement is going to be our functionality for stacking. When we stack an item, we drag one item to another item, and that item is going to be merged in wherever we have dragged it to. So that means that if our data target item ID is the same as the data origin ID, and otherwise these items that I'm dragging and dropping over the other are of the same type, and the data origin stackable is true, we can stack these items, then we're going to merge them together, and the slot from which I have dragged a item needs to become empty. As that becomes empty, we set that first in the data of our inventory data, where the origin slot item and stack are both going to be null. Next, when we update the texture and the label of the origin, I'll be replacing this if-else block again with an if-else block, where again the first if statement means we're stacking two items. We check again for the same conditions, whether the same item and origin stackable is true, at which point we know that the texture is going to be null, since we're emptying the inventory slot, and we get the node stack and we set that text to nothing. And finally, when we update the texture, label and data of the target, I'll be introducing an if-else statement in this section. Again, we check for the same conditions, and if that is true, we are first going to be defining the new stack size by adding the target stack on top of the origin stack. Then we set that data in the inventory data on the target inventory slot stack subkey to the new stack. And of course, we get the node stack and we set that text to string of new stack. With that done, we can play the game. Now, when I drag these two stacks of 2 potions on top of each other, I get one stack of 4 potions and another one 5 potions. If I drag 2 stackable items which are not of the same type, they're simply going to be swapping around. Same happens with a non-stackable item and a stackable item. And of course, these chocolate cakes can be added together as well. Also, our inventory slots remain fully functional, and we can simply swap these around however we like. In the next tutorial, we're going to be having a look at how we can split these stacks again. For now though, I hope that you enjoyed this video, and if you did, please smash that like button, hit subscribe, don't forget that little bell icon to make sure you don't miss out on that next tutorial. Until then, keep on gaming, keep on coding. See you later, guys.